Hello, this is Albert van Dijk, and in this video I want to explain a little bit about active optical remote sensing, or also called Lidar. And as we saw before, that stands for light detection and ranging. And the most common application is really from airplanes, as we'll see later on. What you can see here is the typical configuration of a Lidar system on an airplane, where you see as the plane moves forward, the lidar pulse, a pulse of light, a beam of light, is sent to the Earth's surface and comes back to the airplane. So how does it work? Well, basically the system on board the airplane emits a laser in an optical or near infrared wavelength, and in fact on land typically that would be near infrared. And then it basically measures what comes back from the surface. So as you can imagine, you're looking at a beam of photons in the near infrared frequency, and those photons hit the surface or elements above the surface, return to the airplane. Some of them do, a lot of them of course don't, but some of them return to the airplane, and those are measured. The time is recorded, how long did it take those photons to come back, and from that, with the speed of light, the distance can be calculated to the target. So here's another way of what that system looks like, or at least how the principle works. And as you can see, typically there's a mirror involved that scans from left to right, or from right to left, and maps out the location, because we know the angle and we know the distance, so you can know the location of the returns of the photons of the signal, and so you can map out a picture, if you like, or a model of where solid objects are with respect to the sensor, and that same system is used on for instance Google Car as well, to know whether there's any objects around, and so forth. Now, one important thing to remember is that we don't have a very narrow pulse of light going to the surface. In fact, the further away you go from the aircraft, the broader the beam of the laser becomes. And so, by the time we get to the surface, typically you'd be looking at an area of maybe a few meters if your plane flies very high, or more typically with the lower altitude airborne campaigns, you might be looking at an area of about 10 centimeters or in that order of magnitude. And so you don't get a single return either, because within that small area there will be different objects potentially, particularly in vegetation, of course. You get leaves and whatnot, and so some of the photons will come back earlier, in other words, are higher above the ground surface than others. And that's what this figure shows. So we see here the intensity, if you like, on this axis, the horizontal axis of the, you could think of it as the number of photons that returns to the instrument and is measured there. And so in terms of time increases, and here you get as we call it, the first return, which is therefore also the nearest to the sensor. In other words, is the highest point. And so the first return is often measured by some threshold, looking at this distribution. So you might say, for instance, the first 1% of returns occurs at this particular level, for example. And so in the case of a tree, you'll see more and more returns because of the shape of this tree here. And then it less and less starts returning again, as not only is there less leaves, but also fewer photons that make it through here actually make it back to the aircraft. But within this same footprint, we've got a little scrub, and so we get a second return here. And even if that scrub had been under the tree, you might still get some sort of a shape like this, of the photons that make it through the tree canopy to the shrub, and then back from the shrub through the tree canopy back to the sensor. And then finally, we get what's typically designated the ground return, which is often characterized by being narrower and steeper. In other words, it's a better defined solid object in the landscape, if you like, and also after this, of course, in time after this, there will be nothing returning back to the aircraft. So we call this the ground return, call this the first return, and here's then a second peak, as you might call it. So when we have data like that in an analysis software, it might look a bit like this. This is in Less Tools, for instance, I believe, a software specifically designed to analyze three-dimensional data points. So every point has got an X, Y, the lateral, so let's say the longitude, latitude locations, and then a Z point, as in Z above some datum, and that datum could be sea level or whatever you assign to it, essentially. So we see here a scan for Black Mountain, and we see the Black Mountain Tower here. And here a little close-up of a tree, where you see the shape of the tree, obviously, but you see that some of the photons make it through the tree canopy and onto a branch, probably in this case, and then return back to the sensor. And there's also a number of photons that have made it right through, and again made it back to the sensor. Just want to emphasize, based on the graph that you saw before, when I talk about photons, I'm not saying that every point is a photon. These points, again, represent peaks in the waveform, as you saw that in the previous image. So you can do this in any environment, obviously, and depending on what you might be interested in, you would use the results differently. So if you're interested in the topography of the landscape, for instance, to predict where floods might go if they reach a certain stage, then probably you would get rid of these first returns, because they're the vegetation, they don't represent the ground surface. So you might end up with this here, digital elevation model. On the other hand, if you're more interested in crops or vegetation or forests or whatever, you probably want to know the height, at least, of the vegetation above the ground surface, rather than above some datum. So you probably will subtract this from the first returns that you see here, and then we get a map of the canopy height, again expressed as more or less the highest point in the vegetation, judging the full waveform minus the ground return.